Hi all, today I'm going to introduce to you all equilibrium of a uniform rigid body. Let us start with few questions. State two conditions for the equilibrium of forces acting on a rigid body. Condition 1, total force equals to 0. Condition 2, total torque equals to 0. Condition 1 implies that the sum of the components of forces along any direction is 0. Condition 2 implies that when we take moments about an axis, sum of clockwise moments equals to sum of anti-clockwise moments. Both condition 1 and 2 are necessary for the equilibrium of a rigid body. Questions 2. Define center of gravity. It is the point at which the whole weight of a body may be considered to act. There's two examples here. One is rod and spear. The midway points between its end, we call it center of gravity, or it is the point at which is evenly dispersed and all sides are in balance. Let us attempt a questions referring to equilibrium of a uniform rigid body. A uniform ladder AB length of 10 meter and mass 5 kg leans against a smooth wall as shown in figure below. The height of the end A of the ladder is 8 meter from the rough floor. A. Draw the free body diagram of the ladder. I already mark the two normal forces acting on A and B as S and R. Static frictional force acting on B to prevent the ladder slip off from point B. Weight of ladder on center of gravity and weight of firefighter on the ladder to favor the questions on section B, which is stated the firefighter of max cc kilogram is 3 meter from B. For section B, determine the horizontal and vertical forces the floor exerts on the end B of the ladder when a firefighter of mass 60 kg is 3 meter from B. By using the free body diagram, the total forces acting vertically upwards is equals to the total forces acting vertically downwards. Use the calculator to calculate by substitute the given value. If you don't have the calculator, you may calculate later. So the final answer for vertical force is 637.65 Newton. For horizontal force, take the moment at B. B gonna be the axis of rotation. If B is the axis of rotation, the forces acting on B not involved at all. Torque is the product of force and the perpendicular distance from axis of rotation. It means S times 8 meter. I repeat again, S times 8 meter floor clockwise. for clockwise. Clockwise, anti-clockwise, clockwise, anti-clockwise, clockwise. I repeat again. Clockwise, anti-clockwise. Sorry, it's a bit error here. Clockwise, anti-clockwise. Sorry for the break. I repeat again. Clockwise, anti-clockwise. For anti-clockwise, weight of ladder times XL towards axis of rotation, and weight of firefighter times XF towards axis of rotation. XL is from the center of gravity, so 6 meter divided by 2, you will get 3 meter. To find XF, we have to find the angle, which is arctangent of 8/6 equals to 53.1 degree. Mathematically, XF equals to 3 cos 53.1 degree. You will get 1.8 meter. Torque of clockwise equals to torque of anti-clockwise. Substitutes all the values accordingly, and finally you will get the horizontal force as is equals to 151 Newton. Simple like a bubble without giving you any trouble. Always remember, the horizontal force as is always equals to static frictional force on the rough floor. So the S here equals to static frictional force S. Or take the moment at A. Now A gonna be the axis of rotation. Ignore the force acting on A. Clockwise equals to anti-clockwise. Repeat again. Clockwise equals to anti-clockwise. Torque is the product of force and the perpendicular distance from the axis of rotation. Anti-clockwise, clockwise. Anti-clockwise, normal force R times 6 meter. For clockwise, weight of ladder times 3 meter from center of gravity, and weight of firefighter 6 meter, weight of firefighter times 6 meter minus XF. I repeat, for clockwise, weight of ladder times 3 meter center of gravity, and weight of firefighter times 6 meter minus XF. You may see the clear picture here. R is a vertical force which is equals to 637.65 Newton. You can get it this value from section A, question section A. Substitute all the values accordingly, and finally you will get static frictional force equals to 151 Newton. It shows as equals to static frictional force. Simple like a bubble without giving you any trouble. For section C, calculate the coefficient of static friction between ladder and floor. By using the formula of F equals to mu r, you will able to get the coefficient of static friction between ladder and floor. The final answer is 0.24. Thank you for watching this video. Thanks a lot, and thank you to the lot. Stay safe and take care.